Good evening, everyone, and thank you very much for joining today. And this is a part of this session is the part of our expert talk series. Today, we really have a great speaker with us. I'm so sorry. I think there is some issue with this. Okay. Okay. Am I audible, Shiv?
Yes, yeah.
Okay. Yes. So thank you very much, everyone, for joining in the Expert Talk series of Cybersecure India. Cybersecure India is a non-profit initiative by Feather CSI Foundation, and we are into training and internship programs. Our next free training and internship program is starting from April first week, and the forms will be rolled out by weekend or next week. And stay tuned for that on our LinkedIn page and our Telegram channel. So the current interns also make a note of it, who can share it with the new one. So I again thank you everyone for joining. Today is a very unique topic, and with a great speaker we have. So Shiv, welcome to the platform. Welcome to Cybersecurity India, and thank you very much for accepting our invitation and joining us basically. So our today's topic is OT security. I'll just formally introduce Shiv, and Shiv, you can add on if I'm missing on anything. Shiv is having 15 plus years of experience in cybersecurity with a focused and critical information structure and ICS security. He's also worked on cybersecurity research areas like network security, dark web, OT security, and many more. He has also worked with NTRO, NCIIPC for 10 years. And working with Siemens Security and Trust Research as of now. He has huge consulting experience on industry security on various sectors like oil and gas, manufacturing, chemical, food and beverages, cement, steel, electronics manufacturing, and automotives. He holds cybersecurity certifications like CISSP, ISA IEC 62443 expert, ICS 515, ISO 27001 lead auditor, and many more. In 2021, he was the first to get the training and certified from India on IEC ISA 62443. It's really great to hear this. He is enthusiast of IIoT, Metaverse, and Web 3.0. Currently, he is also leading ISA's IIoT committee under SMIoT, that is Smart Manufacturing and Industrial Internet of Things division. He is firm believer in knowledge democracy and shares useful insights on OT security via LinkedIn. And really, he shares a lot via LinkedIn. I really comment whatever whenever I open LinkedIn, I scroll down and I can see he is sharing some of the other things on security. So, like having such a vast knowledge, we are really thankful that you are joined here, and we are here to listen to a unique topic today. And it is really grateful that see there are very few people who know this type of details and who have worked in detail into this industry, but they are willing to share also their knowledge. So I think Shiv is one of them, and it is a grateful thing about it. So Shiv, over to you. Please add if I missed out anything about your introduction.
No. First of all, thanks, Nikhil. Thanks for inviting me. And this is really wonderful to see that you are doing some pro bono cybersecurity knowledge sharing sessions. I'm really humbled to know that. And I am for this knowledge democracy, which basically giving back to society. I feel that I learned from lots of people, and this is my moral responsibility to share the knowledge with the new aspiring talent. And as you know, India is having a huge demographic dividend, and cybersecurity technologies, Industry 4.0, IIoT, Metaverse, these are the technologies of the future. So how small part we can play, I would be willing to do that. So without further ado, let me just start with the session. And since we are doing it for first time on specifically on OT security, I will be talking as an overview of OT security, and then at the end discussing what are the international standard frameworks that are available. And at the end, as a key takeaway for the people who are joining online, what could be the OT security career options for them if they really want to get into the OT security. Yeah, so you
That
have
would
given a
be
very
yeah, really great that you'll be exploring on the career options also. And also I would just like to tell you if you can also tell about your journey, how you got into this, and then start with the topic, so that it will be again motivating and inspiring for all of them. And for the audience, if you have any questions, you can post it into the YouTube live chat, and I will take it forward to the speaker after at the end of the session, where you can keep posting the questions. Over to you.
Yeah, thanks, Nikhil again. So since I was thinking to skip this slide since you have given a very good introduction, but the reason I kept it here is when you mentioned to share my journey. And just 2 hours before, I had done a podcast with Rashia Perry from Saudi Arabia on that specific topic, sharing my career journey. So I started my career with NTRO NCIPC, which is the apex body for research on cybersecurity topics. And I had done, it is a kind of a destiny for me. When I joined this organization, I have been put into the cyber department, and that's where I learned the basics of cybersecurity. And I got a very good opportunity. Wonderful colleagues are there. Since it was a government organization, we had the freedom to research on the topic of our interest. So with this, I worked on a bunch of topics like network security, understanding the system level security, cyber security audit, ISO 27001 kind of topic, risk assessments. And then in 2014, when NCIPC was created, which is also part of NTRO, I joined NCIPC as the first founding employees of that organization. So I worked on all the critical infrastructures that are part of NCIPC that time. So in 2014 till last year, before the AIMS attack, there were 6 categories of CIIs in India. Now we have 7, that is healthcare. And those 6 were starting from power sectors to transport, communication, and banking sector, government data centers, and the organizations like ISRO, DRDO. So I got a chance to learn about them, what kind of critical infrastructures they are having. How do we, first of all, classify something as critical infrastructure? Because this topic itself, it's a debatable topic. What can you call a critical infrastructure is a very careful assessment. Some time back, a food and beverage industry got impacted in US. And in one of the articles, somebody called that industry is a critical industry. So calling an industry as such a critical industry is not a problem, but if you're calling an organization as a critical infrastructure, that becomes a problem. And that's where people make mistake of understanding and differentiating between CIIs. So cutting short over there, so I worked on CIIs, and 4 years ago, I moved to Siemens. And CII is kind of mixture of IT and OT. And Siemens, when I moved, it is purely an industrial control system, OT organization that develops a lot of technologies. And you see any industry, small or large, you will see a Siemens product there. Even at our homes, you will see Siemens products, either at an electric circuit that you could use a very small circuit, or you use appliance there. So being a big conglomerate, it gives a huge exposure and large number of products that you can work on, large areas of research that you can work on. So 4 years back, when I came here, I got project specific to OT security that could either be into architecting a solutions or doing some research activity over there, doing some risk analysis or threat analysis of a product or service, or giving external consulting. So external consulting is my favorite topic, and that's where I learned a lot from these industries, which you mentioned, the different sectors, power and energy, to food and beverage, to electronics manufacturing, and all of them. And during this journey, I learned a lot. I understood different systems. I got myself certified on these standards, or say certifications like CISSP, which was in my bucket list for last 12 years. Getting the opportunity to learn with a wide exposure actually helped me to achieve these certifications in very small amount of time. So that's my journey. And since 2019 itself, I am associated with the International Society of Automation. And in 2020, they had formed a new division, Smart Manufacturing and IIoT. And I was chosen leader for the IIoT committee, which actually works for sharing knowledge, coming up with templates, formats, frameworks on the topic specific to IIoT. Yeah, that's my journey. And I have a Mumbai connect. I've been there. I started my career in Mumbai in 2009, and I was there till January 2014. And I also attended this Institute of Forensic Science in Mumbai to do my PG diploma in cyber forensics and law. Yeah, so that's my journey. Now, coming to the topic of today, that is OT security. So before getting into the topic, first of all, what do we mean by OT? OT as a abbreviation means operational technology. And the crux of operation technology is the ability to manage the physical process, control, manage, and supervise. Like IT, it is also a mixture of hardware, software, but it majorly rely on the hardware part rather than the software part. We can use these technologies for either monitoring something, controlling something, or supervising something. Like think of an example of something like you're having a bottling plant. So every time you see the bin empty, your eye will sense that, okay, the bin is empty, and your hand will go to pick an empty bottle from the rack. So you can actually automate, you can put a sensor there who will sense, okay, there is an empty station, and then there could be a robotic arm that will go to the bin and pick an empty bottle and put at the area dedicated for filling the bottle. So this is OT. You can actually automate the industrial manufacturing process. And how you will do that? You will require some sensors. And when they sense this, then there would be something that will act on those sensing. And at the back of that, there would be brain. So it's like human thing. Your eyes are sensor, your brain is the program logic, and your hands are actuator, which will take the action. HMIs are the human machine interface. So basically in these ICS systems, when you have programmed something, you need to continuously see how the system is performing. And based on that, you will take some decisions. And HMIs are bigger screens that will show you what is happening in the plant. There could be software HMIs, and there could be hardware HMIs as well. And then at the end, you want to actually observe at the whole plant level, what are the activities that are going on. This can be achieved through a system like SCADA, which means supervisory control and data acquisition. So in a nutshell, that is what OT means. So when you compare OT with IT, there are two key differences. One is OT is primarily used for controlling the physical processes, where IT is primarily your office environment, and it plays around the data processing. Data could be anything, like your Word document is a data, or your salary slip is a data, your customer PO is a data. Whereas physical process, like the same example of seeing an empty bottle and then putting it underneath the filler, or seeing the temperature of the boiler is going very high and then taking a decision to shut off the gas burner. These kind of decisions are taken by the OT technology. Another key difference is OT technologies are generally distributed. So if you have a plant of bottling, you will have a tank where you will store those liquid. Then you will have some mixing system. From there, it will flow through wire pipes, and then it will reach out to the bottling station. Each of these locations will have some electronics involved, and that's what is the part of your operational technology. That's why we call it a distributed system. Whereas IT is more of centralized and standardized. We have standards like common criteria, which will give you a uniformity. So let's say you are using Windows today in an HP system. Tomorrow, if you change your system to Lenovo, you will be not having any difficulty. You can migrate the Windows from HP to Lenovo. But the same is not true in OT. If you are using a Siemens PLC, you can't just simply replace it with a Rockwell PLC or Allen Bradley PLC. Those kind of difference are there. Then coming back to the cybersecurity goal, generally in IIT side, you see CIA triad, which is the foundation of cybersecurity, ensuring the confidentiality, that the data that is there in your office is not seen by the people who are not authorized to see that. Then the integrity, which ensures that there are no modification made by the people who are not authorized to do the modification. And finally, the availability of the resource itself. So you see the confidentiality is put up at the top, and in IT infrastructure, confidentiality is of prime importance. Companies would not want their details of their employees to be seen by somebody else. Similarly, they would not want the data to be changed. When you come to the OT side, the first concern is the human safety. Because see the robotic arm that is depicting the OT system here. If you have seen a recent movie on Netflix where they have actually shown a robotic arm killing a person there. Or another example is they have some movement area in the factory. The robotic arm can either go left or right. So if it takes a 360-degree circle, there are chances that somebody will get hurt. So you really want to ensure the control over that electronics. So safety is the first important thing. The second, next to safety, is availability. You want your plant to be producing at maximum available time. So rather than ensuring the confidentiality of data, you want that the sensors are sending the data continuously to you. And somewhere in between is the integrity. That's what the difference of goals in the cybersecurity for OT. Now, if you compare why the cybersecurity of OT is different from IT, the first one is obviously the safety and availability concerns in OT versus the confidentiality concern, but there are other concerns as well. First of all, the IT system, generally you see in organization, they have a policy of 3 years to 5 years of recycling the systems. They will change the systems after 3 years. But in OT, if you put up a plant, you don't have this luxury. You will put the system from 10 years to 25 years. And I have actually seen when I go for assessments that there are Windows 98 systems being used in some of the plant back in 2019. And they are really having hard time to migrate from Windows 98 to ME, from ME to Windows XP. Then in IT side, there is software lifecycle is also very small. There is forced migration. Windows will say, okay, we have a new update. Then you are forced to update that. And there is another angle to this is you're connected to internet, so you are required to update that. But that's not the case in OT. The software life cycles are also very, very long. And generally, people will use those softwares like HMIs and SCADAs as long as they are not broken or they are supporting the underneath hardware. Also, the security options that you see in IT are available fairly well. You see all the antiviruses, and now we have cloud-based technologies. We have attack defense simulations available. Lots of insights you are getting. But on the OT side, since we have this heterogeneous environment, if you really want to put an antivirus solution, you are not sure whether it will work with the legacy systems or not. So that's the reason the solutions for security are very limited. And also, if you see the heterogeneity that comes from the previous slide, is generally you will see maybe Windows 10 or Windows 11 in your office environment now. But in OT side, as I have given you the example, Windows XP to Vista to 7, all these obsolete OS are still available in the industry. And last but not the least is the standardization. You have common criteria available, then you have ISO available, ISMS, and lots of standards available from US National Institute of Standards and Technology, NIST, which are generally followed by the IT industry. But that's not the case in OT. The standardization is case to case and risk based. So these are some challenges when you see the IT security versus the OT security. Now, in last few years, what is happening is the technology is growing, and this is actually diluting the boundaries between the IT and OT systems. There is a convergence that is happening. You must have heard the terms like Industry 4.0, IIoT. This basically means that earlier when the plant was working on an air gap situation, now the organization really want to have the visibility. This provides a huge operational benefit actually. Like I would be able to only monitor a plant if I'm physically monitoring it. But if I have a software solution that can integrate and give me some nice looking graphs and the performance scale KPIs, then I would be able to actually manage multiple plants. So this is just one example, but the efficiency of people, the process also gets improved when you have technologies implemented from IT side to OT side. And that's where there's an integration happening. What you see in this slide at the bottom are the field devices like the sensors, or say some motors, some actuators. Then there is a control and automation platform like PLCs, HMIs, and then we have edge layer, which could be like your SCADA devices or say DCS systems. Above that is a software layer, and then we go to cloud. But with this integration, also increasing is the risk profile of the industrial control systems. So imagine a situation that you were running a Windows 7 system on a plant, and earlier it was air gapped, and now you have actually took the data to cloud. So now those APIs or say the server would be available for the people to attack over the internet. And since the system was already having known vulnerabilities, it would be very easy for the attacker to compromise these systems. You go to Shodan, just put ICS or say some industrial protocol like 102. You will see lots of systems that are exposed to internet. And that's where people can actually see them and then attack them. So these are the challenges. And if we see the number of threats or the kind of threats that are there for OT systems, they start from malware. But in the last few years, from malware side to ransomware is a huge transition. It is true for both IT industry and OT industry. And more so for OT industry because of the same example that we have those legacy systems being available even today in 2023 for those industrial control systems. Then we have some zero-day issues. Like everybody know about this Stuxnet attack which happened in 2010. There were 4 different zero-day vulnerabilities that is exploited into this particular attack. Excuse me. Denial of service is another example. The Ukraine power grid attack in 2015 was a denial of service attack without any malware, just using the existing vulnerabilities. Then we have man of the middle. So in 2017, there was an attack that came out, which is known as Triton Trisis, and it basically targeted one of the safety systems in the plant. And it was sending the communication at the both side, intercepted, and it was transmitting to the device as well as the monitoring station for this. And again, since the IT/OT convergence is happening, we see lots of spear phishing attacks targeting these organizations. In a couple of slides, you will see how these all threats are combined to have a real attack, which goes to the physical layer of the industrial control systems and impact some process over there. But before that, we'll see how the attacks or the threats have evolved over the years into OT side. So if you see the history, earlier in 1950 to 60s, there was digital information processing systems, which were primarily being used for military and government organizations. Then came the era of 70s, the computers were introduced and digital connectivity started. Mostly into late 80s and 90s, we see lots of computer being used for electrification and automation of the plant. Then 90s, early 90s, the internet came and the whole globe got connected through this. We have mobile flexibility since early 2000. And then we have cloud technologies, Industry 4.0, IoT, big data, all this technology evolved over the years. But when you see the globe got connected in the 90s, you see there is attacks that have started happening around these infrastructures, and it has grown in numbers over the year. If you see the recent attacks, there is attacks like Log4j, there are attacks like the Pipe Dream attack. I think there is the slider that is blocking this, but yeah, that's the message here. You see the CPU level attacks like Meltdown, Spectrum, Intel, and the last one is the Colonial Pipeline as well as the Pipe Dream that was discovered last year. So that's how these attacks are increasing against the infrastructure. So the technology is now readily available to the people. At the same time, the sophistication of these attacks are also increasing. The earlier attack, if you see, they are generally either espionage or learning about the system. You can compare them with the Havix attack that happened in 2014 to the Dragonfly attack in 2018. But over the period, the sophistication is increasing to the level that the current attack, which was to 2017 Triton Tratis, is actually going to the safety system. Now, if we map this back to the goal of cybersecurity in OT system, which is like safety first, it is really impairing the safety side. And now we are actually having targeted attack towards this device. And generally, the safety side of industrial control system is considered secured, mostly because of the Bhopal attack that happened in India in 1984. There was a huge learning from that particular attack, and the industrial control systems were actually evolved around that. In fact, there are some safety instrumented or safety integrated levels, SIL levels available for the industrial control systems that are being used for the controlling and monitoring of critical processes like fire safety alarm. These are the alarms that you really want to work in times of crisis. So they actually are made with the SIL certification level, and they have sometimes redundant CPUs, redundant communications, and redundant memory spaces, so that if something goes wrong, they are able to perform. But the sophistication is increasing, and the attackers are actually targeting these systems now, and the industry need to pick up on that side as well. Now, there is a marked difference between the OT cybersecurity kill chain versus the IT kill chain. There are two stages involved into an OT attack. For a successful OT attack that actually targets the OT system. So far, there are only 7 known OT attacks that have targeted the physical processors, going to the actual actuator or sensor level and then impacting something. Since 2010, this first one was Stuxnet and the recent one is Pipe Dream. But there are close to 43 attacks in last, say, 25 years or so, which have targeted the industrial control systems, and they have impacted various levels of the ICS. In next slide, I'll be sharing how does an OT architecture looks like. But before that, this is the ICS kill chain. So generally what happens is there are 2 stages. The first stage is purely to gain and command and control center and some shell to the system, and also learning the system. So if I give you the example of a Stuxnet attack, which happened in 2010, and it actually has impacted the Natanz nuclear facility. The actual traces of the malware goes back to 2006, and it is actually being told that the initial 2 years from 2006 to 2008 was the stage 1 of the attack. Understanding the targeted environment, then designing the exploits for delivering the second stage exploit. and then ensuring that we have a persistent connection to the target infrastructure. And normally in ICS stack, the attacker would basically try to have more than one persistent shell available, or say delivery mechanism available, so that if one fails, they are able to deliver the payload, stage 2 payload, through the second option, which is exploited in the stage 1. In stage 2, they develop a payload which is specific to some physical device. It could be a PLC, it could be a IID device, or it could be a SCADA system or DCS system. And at the end result of this, we see a catastrophic impact impacting a physical device as such. This is the architecture that shows how does the general OT system look like. And this layer 4 is generally the enterprise layer, from where you will control the general information systems. Let's say, how would you manage your people in the plant? How do they exchange the emails, the DNS servers, the domain controllers, and planning of the production, like MES solutions. Then there is a DMG layer, which is not available in all the cases, but generally this is assumed that there is a DMG layer, which is called the industrial DMG, which separates your enterprise layer to the actual ICS layer. And within the ICS layer, there could be 4 different levels. One is the control of the complete plant, which could be a ICS specific domain controller. Then there are engineering station, manufacturing execution of OPC servers, data historian, which would store the complete data of the site. And then there are supervisory controller layer 2, which could be like in the previous example of the bottling, you really want to see how is the specific bottling plant is doing. So for that, there could be one supervisory control. And if there is another system which is taking care of dispatch, then there could be another supervisory control system available. And the automation goes on and on for the plant. So from layer 0 to layer 2, you can see multiple systems. From layer 3, 3.5, and 4, generally it's like one system that controls the multiple systems. So in the previous cyber Tilchin, when I was explaining going to layer 0 or layer 1, the attack actually reaches to this particular layer. And that's what the impact of the attacks like Pipedream and Stuxnet. Now, the question is, how can I secure? I now know the challenges, I know the problem. So the answer to that is to have a 3-dimensional approach covering the people, process, and technology. And people is very, very important aspect of industrial control system security, because most of the knowledge of running the plant is in their minds. They have learned it through the experience. And now, when you are securing the plant, you really need to document that. It could be a risk, not in terms of cybersecurity, but also a business risk. If somebody who is having this knowledge aggregated over 20 years, when they leave the organization, that also could be a challenge. So this 3-dimensional approach targets evaluating the awareness of people in terms of cybersecurity. And the second one is to understand the policy procedures that they have created for mitigating the risk. And third is also looking for the technologies that are there. So generally, the process part are very strong for plants in terms of the production side, but they are very weak in terms of cybersecurity side, because that was not their forte. These systems were designed with production in mind, not security in mind. So there is a concept that is borrowed from the ancient kingdoms, which is called defense in depth, which also works in the IT industry as well as in OT industry. And what we see here is, in a plant, assume the plant is concentric circles. The first one you want to achieve is the perimeter security, which is physical security of the plant. And then the next layer is to your network security of the plant, ensuring the firewall network access level is available. Specifically, when you see this architecture, like you are giving remote access. So you really need to ensure that this remote access is secured. most of the ICS attack are actually get into system through this remote access only. So we really need to ensure that the remote access and the network level security is available in the plan. The next layer is obviously your systems or endpoints like Windows endpoints. This can be secured through host IDS, host IPS, or say antivirus solutions. The previous systems like Windows, old flavors of Windows might have some challenge there, but the new systems now work well with the newer solutions of antiviruses. Then we have network security of ICS communication. Traditionally, the knowledge of ICS communication protocol were not available. Now, recently, the solutions like Clarity, Nozomi, OT-Pass, and Tenable OT, they have very good understanding of ICS protocol, so we can actually use them for monitoring the security at the ICS network. And finally, the security for the end devices. So these devices generally comes with the protection level, and there are various standards like 62351 for security of 61850 protocol, widely used in the industry, specifically the energy industry, which tells how can you actually secure the device through crypto mechanisms or say PKI certificates or having secure enclaves in the endpoints. So with the people, process, and technology, there is one more important aspect is communication, and this is very, very relevant in ICS since the systems are very, very time critical, specifically when you see the power grids, they are very, very time critical. So we need to ensure that the availability of network is at a very high level when we see the security of ICS as such. So I'm using the term ICS and OT interchangeably because they both mean the same generally. ICS systems for industrial control system, and OT is the operational technology. Now coming to the standard, there is one gold standard available for industrial control system. It is known as IEC 62443. Though there are other standards, region-specific standards like NURCSIP in North America, then there are NIST documents 882 available. In Singapore, there is CSA. Then in Middle East, there are a bunch of standards that are available by these countries. In India, there is NCI-IPC control guideline available, CEA guideline available. But if you see one global standard that is accepted for both critical infrastructure as well as the digital manufacturing side, that is IEC 62443. And this standard's beauty is it actually covers all the aspect of the organization, starting from the policy and procedure level, which is like having the ISMS kind of thing, which is in 62443 language called as cybersecurity management system, and then giving the procedures for patch management to going to the maturity levels in 2-4 to finally the implementation guidelines. So the standard is basically divided into 4 parts, and different sections of a standard apply to different people. Generally in ICS, there are 3 major actors that play. One is the OEM that designs the system. Then there is a system integrator who will commission the system. And then the third one is the asset owner. So you see this language is used. Service provider is like somebody who will ensure that the plant is working. Asset owner is the owner of the plant. And then there is system integrator who will see what is the specific requirement of the plant. These systems are not available commercial off the shelf. If you really want to build something like an automotive plant, your requirement would be different from Hyundai to Honda because they are generally have different kind of parts, so different kind of molds or technology might be required, and system integrators play a very crucial role there, specifically in the traditional industry like steel manufacturing, cement manufacturing. So we need to ensure the security across the life cycle, from the OEM who is building the product to the system integrator who is configuring the product and the asset owner who is running the plant. The standard basically talks on all of those areas. This 2-1 series is specifically for policies and procedures. 3- series is for the system levels, and then there's 4- series, which is for component level or say product levels like a PLC or say SCADA or say HMI. So the standards beauty is actually designed based on risk. A small time manufacturer somewhere in the remote area producing maybe a truckload of the food would not have same level of cybersecurity risk compared to a energy utility. And the standard has actually um, documented this well, explained this well in terms of security levels. So there are 5 security levels, level 0 to level 4. I did not mention 0 because 0 means there is no security. So let's say there is a system which can be attacked from the insiders, or say some rookie hackers going to Shodan and then using the default credential. So if you really want a protection against that, then you want to apply the security controls which are given in security level 1. But if you see a bigger adversary to you, like Stuxnet, which was told that there are 2 countries that collaborated to attack against Iran's nuclear plant, then you require technologies which are according to level 4 of IEC 62443. So there are huge difference in terms of technology requirement, and since security comes with a price tag, the risk assessment is very important part of the organization's cybersecurity program. And based on that, the decisions are taken, what kind of security would be required and what security level they will comply to. So this basically summarizes what is the security, what are the standards available. Now, before we open for the case, there are just 2 more slides that I want to discuss over here. That if the people who are joining online and the people who might see it later, if they really want to get into OT security, there is a path that they could follow. And this path is based on my experience, how I learned and how I have seen my colleagues growing. So the first thing is it's an optional thing, which is learning a language. Why it is optional is it depends on what career you will choose after getting into the OT security. You really want to go into testing the product, then you really need to learn this. But if you want to go into architecting the security solutions, then you might not require the programming language. Specifically in today's scenario, when you have ChatGPT available, you can really solve the smaller problems asking to ChatGPT. Then the next step is to learn the cybersecurity aspect, what kind of security and security is applicable to ICS. There are a bunch of resources that are available. I have actually jotted it down in one of the article or LinkedIn. So you can go there and check. And the next step is to learn the requirement specific to OT security and ICS. And this is learning like how you can secure a PLC, what kind of attacks are possible on PLC, what kind of attacks are possible on HMI or SCADA systems, the software aspect, the hardware aspect, the embedded aspect, all those things. And also learning the international standards which are available around industrial control system. IEC 62443 is just one of them. And once you learn this, then very important aspect of this is practicing those learnings. And generally, when you attend some training or learn from books, these things are generally written by a perspective in mind. If a trainer is training, he will have some test setup and he will give you the training on that test setup. But when you actually practice, then you will see what are the real world challenges. A PLC, which is configured for a demo, it might have 3 or 4 lines of ladder logic. But a PLC that is working for the plant, specifically the Siemens PLC S7-1500, which is very, very sophisticated PLC, it might have huge ladder logic built into it. So the practice is very important part before you really want to transition in a job into the OT security. And the best way to do it is to connect with the people who are already working. I generally get approached by lots of people on LinkedIn, and I try to help them with whatever way possible. Sometimes I get interview scheduled with them, discuss with them. Sometimes when I feel that they are worthy to join, I help them join. And sometimes when I feel they need to learn something more around this technology, then I guide them for learning those topics. So now the last slide is, once you have learned this, what could be the career options that you might see? So there could be, this list is not exhaustive. I have simply put up into 3 different categories. One is going into the research and product development field. So you start as a researcher, then you get into an expert area or expert level thing, or say architect level thing. Then you get into a principal level career, and finally head of some research group or say some product development team. And finally, you can go up to the head of technology level thing, which is generally called CTO in the industry. Similarly, in the manufacturing side, we start with the analyst, and there is huge descriptions that I had given on my LinkedIn post. This requires maybe a bigger call for to explain each of these career paths. But yeah, there are a bunch of options available based on your interest area that you can actually go either in consulting, or say organization, or say research area. And there are a bunch of certifications that are available to achieve this. Sense actually gives 4 different certifications. IC 410 is a training cum certification. Then there is 515 training cum certification, and 610, which is only training. And there is even one more for managers, a small 2-day course available from Sense. Then ISA 62443 training cum certification is also available from ISA. And in India, ISA Bangalore chapter or Pune chapter and Delhi chapter, they do conduct these trainings very regularly on a heavy discounted price. So if you really are looking to get into that, those options are also available. Yeah, so this is all from my side, and now we can take some questions. Nikhil?
We have questions from the audience. I will,
Okay.
I will tell you one by one. First question is from Madhav, who is asking about, can you elaborate about the Mumbai power grid attack? That is what his question is. And then, so explain the case study of Mumbai power cutoff, which happened in the year 2020, I believe in October 20, right?
Yes.
That is one question. And then there are 2 more questions we'll take.
Okay, so there are 2 different reports that are available on Mumbai power attack. I know the professor who has investigated this, and I spoke to him. So 2 different theories that are going around. There is one report, and the investigation report by the professor is also available publicly. So I can actually put up a link later on my LinkedIn profile if you really want to read about what was the investigation report. But there is one recorded future webinar that had actually shown that it was a targeted attack from China. They have been doing it for quite some time. But this is actually, there is no actually a binary answer to this, whether it was a targeted attack or an insider issue. But when I learned it, I can't comment on that at this forum, but the report will explain you why did the internet system actually failed over there.
Okay, and then we'll move to the next one. So Larvi is having a question. First of all, he's appreciating the session. He's saying thank you very much for this session.
Thank you.
And he's having. Yeah, am I audible?
Yes.
Okay. So the next question is from Larvi, and the question basically from Larvi is he is having 2 questions. How can an organization better prepare themselves for a cyber attack on their OT ICS system? And the connected question is, can you describe any emerging technologies or approaches that shows promise in improving the security of OT ICS systems?
Okay, yeah, very, very good question. So it shows that Larvi is having some good understanding of the space. So yeah, so one aspect that is missing in currently the cybersecurity approaches to the organization is active cyber defense. All of these standards that you will see, they are mostly maybe I would say that even ISA 62443 is 90% is passive defense. It will tell you, okay, this is your risk, implement this technology. But the other aspect is having the ability or resilience to come back from an attack. That is generally lacking. And this is a huge skill intensive task. You really need to train the people to investigate an attack and then come back from that. So I think that is one emerging area that's being picked up. And there are a bunch of companies that are working into that area. Some of them are doing simulation of attack surface. Some of them are giving some virtual simulation environment to attack and defend. And specifically the EU's Resilience Act coming into effect. These kind of things will be seen more and more in coming years.
Thank you very much for this wonderful answer. So I just wanted to ask you if you want to give any type of closing statements and any suggestions basically for the people who want to come into this field and closing statements from you.
Yeah, so I would encourage people to consider OT security as a career option, first of all, because I found this is to be one of the niche area and the whole industry is impacting in the recent recession, but cybersecurity is the one area that doesn't get impacted heavily when you see. And specifically in cybersecurity, again, this OT security is a niche area. This is picking up, so I would encourage more and more people to join this. And I'm always open to discussions and taking some sessions if people will reach out to me or
so do connect with him on LinkedIn. He really shares a lot of insights over LinkedIn. There are, I think, 2 more questions, and we'll take this as the last one, and then we can close on. How relevant are IT security attacks to OT security attacks? Does any organization requires 2 separate teams to manage both, or one team having capabilities in both areas?
Okay, so again, this is a very good question. I will tell you the reason why it is very important to understand the difference between this. Is currently the discussions are going on establishing the OT security operations center. So the first level of analysis can be done from your existing workforce, which is working on the IT side. When you really need to investigate onto the deep technology of ICS, you really need people who understand the both side of the world, or the IT people will sit with the operations people from the OT side and then understand the technology that are involved into the industrial control system. Now, coming back to the question of having 2 different teams. So I would say not 2 different teams, but a mixture of people that are working as an objective of cybersecurity for the organization. If we have 2 different teams, then it will go into the same thing, the blame game. The OT side will say, okay, it is not my responsibility because the attack is coming from the email server. And when there is an attack that is coming from the lower side, the IT team will say, it is not my responsibility, it is coming from your field device. So integrated team is the answer to that. And that's how I think the industry will grow.
Yeah, so the connected one last question here is, Anish is asking, to get into OT security, you said the prerequisites is to learn computer or network security and control systems. Are there any good resources to get into it?
Yeah, so I have already, so if you see the same slide I have used into one of my LinkedIn posts, OT security 0 to hero, and I've listed down a bunch of resources. So again, I reiterate, there are one very, very good book by Pascal Ackerman, Industrial Cybersecurity. It has 2 versions, version 1 and version 2. So read both of them because they are iterative. They are not like the revision 2 is not like rewritten from the previous one. He has actually explained some part in the first version and some part in second version. That could be the very good resource. And then the second resource is lots of articles are available on ISA's website. The third one would be SANS resource library. which gives bunch of good articles on industrial control system security. Yeah, so these are the 3 resources. Apart from, I have actually put up a huge list on the article.
Yes. So thank you very much, Shiv, for joining and answering all the questions also, and taking this session. And we wish basically you can take more detailed sessions in future, and whatever you wish to, and whenever you have time. So we will arrange more sessions, and our audience also loved it a lot. So really, thank you very much for today's session. That is what I'll say.
Thanks, Nikhil. Thanks for organizing this. I really look forward to more sessions and discuss more on IT security.
Yes. So thank you very much for the wonderful audience for joining us today. So thank you very much. Let's meet at the weekend. Okay. Thank you. So, thank you, Shiv. So we'll end the session today now. Thank you.
Okay.